Assalamualaikum. My name is Nushinda Basumurthy and I'm from Group Project Potato. Our project is all about human body monitoring system where we can calculate oxygen saturation level, temperature, and also the heart rate or ppm. We have used SpO2 sensor, which will give us two output, SpO2 in percentage and heart rate or ppm. Our second sensor is a temperature sensor, which can simply calculate the body temperature in both Fahrenheit and Celsius. Let's explain the SpO2 sensor, where we have used a CNY70, which is a reflective sensor that includes an infrared emitter and phototransistor in a loaded package which blocks visible light. We know in SpO2 blood containing lots of oxygen absorbs more infrared light and lets more light pass through it. Blood without enough oxygen absorbs more red light and lets more infrared light pass through it. We couldn't find any built-in SpO2 library. That's why we have built our own SpO2 sensor and connected with a Simulino Uno. This one. Here we have given 5-volt power to the battery and we have used one amplifier and capacitor, two amplifiers mainly. Absorption of the light takes place at two wavelengths, but the sensor gives very low power output. That's why we have used two amplifiers so that the output signal can be amplified. We have also used five registers here, and also three active variable registers. With them we can change the output mainly. We have also used four more registers down here, and a relay which can which mainly use which is really used for real-time interface during simulation. Also, it can detect the intolerable condition, which is with an assigned area, so that it can protect the system from damage by giving command to the circuit breaker. We can run this and see our output in the LCD now. Well, let's run it. I have already used the Arduino here. You can see the ppm is 82 and SpO2 is 8% now. And you can also see the temperature is 26 in Celsius and 78 in Fahrenheit. Let's change this, okay? Well, I'm increasing the power. Let's increase it a bit more. I'll give it 79%, yeah. And I'll also increase the temperature. Okay, let's see the output now. You can see now the temperature is increased. Now it's 87 in Fahrenheit, and also the ppm is increased. It is 118 in ppm, and the ppm is also increased. It's 118 now, and the SpO2 is 11%. Thank you so much.
My name is Simon Avijit Biswas, and I will describe the Arduino code part of our final project. Firstly, we imported liquid crystal library, variable sensor pulse, LR and LI for measuring temperature, heart rate, and oxygen in blood. In setup function, we defined A0, A1, A2 pin to receive data from heart rate and SpO2 sensor, and pin 5 to pin 7 will be used to transmit data to LCD output. Visualize 16 into 2-dimensional LCD screen. Then we use 00 and 31 cursor to display instrumentation and medic work. We use 00 and 01 cursor to display pulse oximeter and patient work. Value of variables will be updated by the data we receive from the sensor. The map function will take the value of LR and convert 40 cursor will be used to display the word ppm and the value of LR. 80 and 130 cursor will be used to display SpO2 word and the value of LI. If the value of LI is less than 90, 7 and 5 pin will be in high state, and this message will be shown in the display. If the value of Li is greater or equals to 93, the 6th pin will be in high state, and this message will be shown at the L. Vout variable is used to receive the data from temperature sensor. Temp C will give the data in Celsius, and temp F will give the data in Fahrenheit, and these lines will be used to show them in virtual terminal. Thank you.
Hello, Assalamu alaikum. I'm Tunji Tajalli and I have done the lab view part. Firstly, in the front panel, I have taken a thermometer to measure the temperature. Then from numeric, I have taken two numeric indicator to show temperature and SpO2. And I have taken a visa resource name that identifies the resource on which VI operates. It also differentiates between different sessions of the instrument driver. It is used to select the component. Also, I have taken a heart rate chart to show the heart rate. Next, in the block diagram, I have started working for serial port part. To clear buffer, I have taken visa clear. Then to open it, visa open. As we will read 3 string, so I have taken 3 read visa. To finish it, to flush it, I have taken a flush buffer, and at the end and the end to close it, I have taken a visa close, and to handle error, I have taken an error command. Then this symbol is to convert integer to string. Then this one is to is used to delay function. Then I have connected all these converters to visa read. Visa read to is connected to visa clear, open, and flash buffer and close. Then I connected these converters and visa resources with the thermometer, temp, and SpO2 port and heart rate chart. Thank you.
Hello, I am Lubaba Tasnia. I did the connection part. I have connected all the components of Proteus and LabVIEW. At first, I have to open virtual port and create a pair of port so that it can show the data flow from Proteus to LabVIEW. So in this case, I created COM3 and COM4 pair. Then I need to run the Arduino code by clicking verify. After compilation, I need to select the hex file and copy it and paste it in the LabVIEW's Arduino part here. Then I need to select the COM pin of Proteus and physical port. I have to set the physical port COM3 and physical baud rate 9600 and virtual baud rate 9600 also. And now I need to go to LabVIEW and select the visa resource name to COM4. After that, if I simulate in Proteus, we can see the temperature, heart rate, and SpO2. Now I pause this and go to LabVIEW. We need to show our result both in LabVIEW and Proteus. So my task is to run Proteus and LabVIEW simultaneously in order to get the result both in Proteus and LabVIEW. So now if I start running Proteus and then start running in LabVIEW, and I also need to simulate it in Proteus. So this is our desired output. In LabVIEW, we can see the heart rate and also the SpO2 and temperature. We can also check the data flow from COM3 and COM4. COM3 is used for Proteus data flow and COM4 is used to LabVIEW data. So COM3 is sending data to COM4, which is Proteus, to LabVIEW. So this is all our project. We can this project basically shows the heart rate, temperature, and SpO2. This will be very helpful in the current pandemic situation. Thank you.